We all know that curly arrow mechanisms are a crucial part of A-level chemistry, and exam questions like this one are all about application. Here we've been presented with an unfamiliar template for a curly arrow mechanism, and it's our job to predict the curly arrows using our knowledge of things like electrophilic addition, nucleophilic substitution, and so on. So what do we need to do in the exam to approach a question like this, and what kind of strategies can we prepare for in our revision? The first thing to appreciate is that we have to tackle this in stages. For example, in stage 1, which would be from left to right just here, we are adding curly arrows here to explain the structure of this intermediate over there. Then in stage 2, which would be down here, we are adding curly arrows to the intermediate to explain the structure of the final products. So you've got to break this down into stages. When adding in the curly arrows to demonstrate the movement of the electron pairs, we do a strict comparison of a before and after for each stage. This allows us to take focus on what we are meant to be considering one step at a time. Take this first stage, for example. Ask yourself, what changes in our before to the after? In the after, we can see the carbon atom is now bonded to what appeared in the before to be alongside our original organic main structure. We've also been given a clear lone pair to play with in this structure on the left-hand side that I've just highlighted in the pink for you, and we know a curly arrow shows the movement of an electron pair. And so this lone pair is being used to form a new sigma bond to the carbon, so the curly arrow needs to go from the lone pair right up in the face of the carbon atom just here, like so. Curly arrow mechanisms kind of follow a one-in, one-out system when it comes to electron pairs, and with a new bond being formed here to the carbon atom, an electron pair needs to move on to make room. Looking again at the after structure, we can see that the once double bond between the carbon and the oxygen is now a single bond. So let's just highlight that up. We've got a single bond here between the carbon and the oxygen. And if we look at the original before structure, we can see that that was once a double bond. So we've still got a sigma bond feature between the carbon and the oxygen in the after, but originally we had a sigma and a pi. So the pi bond has gone. So our second curly arrow suggestion needs to demonstrate the electron pair in the pi bond moving up and onto the oxygen. Here we go with the curly arrow then. We're going to move that up and onto there like so. And actually this whole starting point over here on the left bears a very close resemblance to nucleophilic addition. We're going to do something a bit different next in stage 2, but this whole starting point in terms of comparison to something that actually is quite clearly on your A-level is nucleophilic addition. Let's move on to stage 2, and to make some room but to focus on the curly arrows, I'm going to get rid of the highlights so that we can concentrate on new curly arrow movement, and I need to re-establish, because I'm now concentrating just on stage 2, my before and my after. There we are. So moving on to stage 2, and once again we need to box off the stages and concentrate how we add the curly arrows to the intermediate to get to the final products. So we need to focus on how we're adding curly arrows here to demonstrate the movement of the electron pairs to create the products down there. I think the first thing to address is the C double bond O, actually from before over here, appears to be getting reformed down there. So we need to find a way using curly arrows to represent this. The lone pair and negative charge at the oxygen at the top, so let's just highlight these up. There we are. These are a big clue for what we need to do. To use the curly arrow to form this pi bond, so to re-establish this carbon to oxygen double bond, which has got that sigma and pi feature, to re-establish the pi bond, we need to push the lone pair between the two atoms, not to the carbon. It's a bit different here with our curly arrow endpoint, partly because we already have a sigma bond between the two atoms. So when I show this curly arrow, I'm not going to show it going here to the carbon atom. That would be a mistake, because we've got that pre-existing sigma bond. What I'm forming now is a pi bond between the two. So I'm going to show the curly arrow going between them like so. Please be very careful with this one. Again, if you were trying to link this to another mechanism, if you were actually on AQA's A level, you do a mechanism called nucleophilic addition elimination, and this is one of the stages in that. So I'd recommend having a quick look for that to see how this one compares. And just to reinforce what we achieved by moving that electron pair to that location is reforming this full double bond just here, which has now got that pi bond brought back in. Next up, and we need to figure out the other product and land our final curly arrow. Clearly between our before and after, we are missing the chlorine. If you haven't noticed this already, if we have a look at the before here, we've got a carbon in a single bond to a chlorine, and then in the after, we haven't got the chlorine. So I'm assuming the chlorine is either entirely or part of what goes onto this line just here. To make room for that new pi bond that we've just formed, another electron pair needs to move over and kick off the Cl at the same time. So my curly arrow needs to make room on the carbon so that it can form this pi bond. So we need to make sure that we're forming this bond here. So this carbon needs to have a little bit of room made around it. And we also need to kick off the chlorine. So the next curly arrow is going to go from this bond onto the chlorine like so. And when we show this second product, we've got to be really careful that we demonstrate the chlorine on the line as having a negative charge, because it's going to be picking up the electrons from that covalent bond, one of which it contributed, but the other is an extra because it came from the carbon originally. And so that means the chlorine is now going to have a negative charge because it has one extra electron, making it a chloride ion. A common mistake here is to actually, and I'll demonstrate this in a different colour, show this curly arrow going from the carbon across to the chlorine like so, but that couldn't be further from the truth of what's happening. Remember that your curly arrow needs to demonstrate the movement of an electron pair, and the carbon atom is not an electron pair source. Thank you very much for watching, everybody. If you did actually manage to miss volume 1 in this series, then there's a link on screen to it now, along to links to my other content relating to organic chemistry. Until next time though, happy revising.